Welcome from the Things conference with a new video interview. Hi, who are you and what do you do?
Hi, my name is Rob Spurrett and I'm pursuing Internet of Things based on satellite, so trying to extend the coverage of the Internet of Things to global, accessing every single spot we can.
Wow.
A big challenge.
To elaborate.
So we have been working on sort of the technical aspects of trying to make sure that we can receive or send LoRa signals from nodes and sensors on the ground, making sure that we can actually receive those on a satellite. I've been doing lots of testing with balloons and theory and lots of benchtop tests. We've now got to a point where we're going to fly a spacecraft in August of this year to actually demonstrate the principle from space, because there's only so far you can get in doing all the testing on ground before you actually get to the point of saying we've got to do this for real in order to prove to people that it's going to work, and hopefully that'll be later on this year.
Okay, so what is the biggest challenge that you're trying to overcome?
Well, there are several technical challenges. I mean, firstly, there's obviously the distance that you have to transmit the signal, and so typically the sorts of orbits we're talking about a spacecraft that is about 600 kilometers up. But of course we're not transmitting to it directly when it's over our head, so sometimes the path to the spacecraft can be very much longer than that. So that kind of adds up to be distances that are very long in comparison to what we normally think of transmitting LoRa signals over. But of course we've got the benefit, we're going straight up, so we don't really have the problems of the curvature of the Earth or all the other sort of buildings and multi-path problems that you get when you're transmitting from point to point on the ground. So distance is first thing, but I think we've proven that quite extensively now with balloon flights, that we can actually transmit over the distance with the required sort of path loss and still have some margin there. So that's the first one. The second one is kind of the whole Doppler effect, the fact that these spacecraft in low Earth orbit are moving really fast. I mean, they go around the Earth in 100 minutes all the way around. So, typically they're moving sort of 7.5 kilometers a second, and you get quite a big Doppler shift on that. So, typically you can get sort of 20 hertz or so frequency shift as it comes towards you and then away from you. So you've kind of got that problem as well to deal with. But we think we figured out ways around that. And then finally, there's one of the business case. I mean, the whole thing's quite expensive to do. Although the cost of getting satellites up there has come down a lot, it's still not really cheap. So we've got to try and make sure that we've got a really good business case for this. And yeah, we're making good progress. We keep identifying more and more use cases that we hadn't thought of, weird and wonderful things that helping us build that business case.
Yeah, but that's exactly the thing that came to mind. Is okay, it's a great idea from a technological perspective. It hasn't been done, so why not do it? But then, why would you do it? Who needs this?
Well, that really, you just need to look at the maps of the coverage of Earth, and you just sort of see how much around where there's just absolutely no connectivity whatsoever. So although we're kind of very lucky, we're used to having connectivity everywhere we go, and we get very upset when we can only get 3G as opposed to a 4G reception, and so there are lots of places where there's just nothing even close to that. So any application where you're kind of moving out of a developed area, even just sort of several sort of rural areas, a lot of the time coverage is very poor. And so satellites can just reach places that other places can. And they can tend to do it really cheaply as well, because they cover a lot of ground because they move so fast. So although the satellite itself is fairly expensive, if you were to try and cover the same amount of path or ground that satellite covers during its orbits, it would be much more expensive to do it with a traditional sort of set of gateways. So we kind of see the system as a complement to the other network of gateways that's being built up, with just the bit that adds on and reaches into the places that those gateways just probably won't ever be established because there's not enough demand for it.
Because you mentioned gateways, because from a technical point of view, it's not like every single sensor or everything is communicating with a satellite. It's networks that go to a gateway, and that gateway is
Yeah.
connecting with the satellite? Or
Oh no, in this case, the thing that's really different about our concept and what makes it particularly challenging is we're trying to go directly from our sensors to the satellite. So the satellite is the gateway itself. We're reaching right up into the sky from the sensor. That brings loads of benefits to it. We don't have the expense and the cost of sort of what the traditional architecture would be in satellite communications, where you have some sort of modem that accumulates or aggregates the traffic from all of the sensors and then sends it up. No, we're going to go straight from the sensor. That's the intention, because everything we're doing, we're trying to keep the cost really low. We have to keep the cost low because we need to make sure that we can get the volume of sensors participating in this high enough in order to close our business case. It also gives us a big benefit that we can work off the battery power from the sensors themselves, because we'll be just using standard transmissions at 14 dBm in Europe and going straight up to the spacecraft. So that means that we can do this and offer people connectivity where there's just no mains power. Very often in these remote places where there's no Wi-Fi, there's also nothing to plug into to get power. So yeah, that's the basic concept.
Talking about power, I mean, Laura, is about low energy. How do you need specific sensors, or can I also use traditional sensors? Do they have enough energy to reach the satellite?
Yeah, the idea is that we use exactly the existing sensors. It will need some slight modifications to the firmware to adjust the radio properties, but essentially it's the same hardware. The idea is that we can do some very minor updates to the firmware, and you could, in principle, go and buy an off-the-shelf sensor and connect it into our system. Once again, all driven around trying to keep the costs down.
Fantastic. So, what about latency?
Yeah, latency, of course, is the downside. In the sense that, you do get some latency of the signal to a LEO spacecraft. It's not as long as the sort of 3-second dropout that you get to a geostationary spacecraft, the one that makes speaking difficult. But really and truly, the issue is kind of like when you have a satellite in view. So, of course, if you just rely upon one satellite, then you'll probably get a sight of that 1 or 2 times a day. But the idea is that we intend to build up a constellation of spacecraft. Many of these sort of new space projects are all based on lots and lots of these tiny spacecraft, all in very slightly different orbits, so that you can get good coverage. So, in principle, if you have enough satellites up there, you can get down to a couple of 100 millisecond type latency. But I suspect that the business cases we'll be closing will be looking at things that are not so sensitive to latency. I think we'll be looking for applications where just want to transmit data infrequently. Time is not important. It's just a matter that there are just no other options available to transmit the data.
Especially in these rural areas where nobody or nothing else is there. So yeah,
absolutely. So one can imagine sort of applications like, say, water meters, metering system, whatever. In the middle of nowhere. It doesn't particularly matter when the latest measurement from that meter gets relayed, or an environmental sensor maybe where tracking the temperature or some other sort of parameter. Doesn't much matter whether it gets relayed, within 10 minutes, an hour, probably several hours. It doesn't much matter as long as it gets relayed eventually and time stamped. Then it's very useful to people.
It sounds like a really massive project because you have to do hardware, software, airplanes, whatever. And do you have a strategy where you have a big community involved in developing certain things, or do you want to do everything yourselves? Or?
Well, we're very much about doing the connectivity. I mean, ideally, we don't really want to do even the satellites ourselves. What we would like to do is build these payloads and host them on other people's spacecraft. That's a very common way now for these sort of startup businesses in the space industry to actually get their businesses off the ground, is rather than sort of have all the cost and expense of flying a big constellation of spacecraft. You actually just host your payload in a little bit of space that's left over on somebody else's spacecraft, and then you pay them. So there's that side of it to develop. I mean, we're very blessed in Lacuna that we've got a really good team. We tap into some great resources elsewhere. So tapping into the help from Nicholas from Semtech, in particular, and Andreas from Parametric Engineering as well. We're kind of bringing a lot of the resources to bear that are out there developing sort of the IoT infrastructure, and they're already working on it and a long way up the learning curve. We couldn't do it without them. And then, of course, there's the whole network of, the Things Network, for example. I mean, we need that. We're relying upon that infrastructure to build out and be vibrant and to be thriving in providing IoT connections over urban areas, and we'll just help fill in the gaps.
Right. So if you look at LoRa right now, because you're using LoRa technology for this, and to the future, are there certain things or challenges that you see that need to be fixed for LoRa itself?
Yeah, I mean, LoRa, of course, always we could, there's trades involved in any sort of radio communication, principally that one of sort of power, data rate, payload size, and distance. I mean, you can sort of get any two out of the three, but you can't get all three. So, for us, I think everybody would like bigger messages, they'd like faster data rates, but power is the trade all the time. So because we're very much sort of striving to try and keep these devices to be battery powered and lasting for a long time, anything that kind of helps us kind of keep the power consumption down really helps close a lot more business cases, helps us access more use cases. So we're very excited in all the sort of developments that are happening on the geolocation front. Especially if that helps us sort of geolocate with great precision, but without having to rely upon GPS chips or GNSS chips, because that brings an additional cost and, of course, an additional power. So really interested at the conference to hear some of the developments that are going on with respect to geolocation. That's very interesting to us.
All right. Well, thank you very much. Thank you for watching. We have a lot of videos with interviews with people of the Things conference in our YouTube channel, so watch them all.